This might be one of the longer videos that we do, but it's the most important skill of 9th grade Algebra 1 that you'll use the rest of your math career that you haven't learned previously. So we're going to start with this little warm-up to get us thinking on the right path. Anytime you multiply two numbers, if I'm thinking of any two numbers, when I multiply them together, I'm going to get 0. What can you tell me about my numbers? If I multiply two numbers and I get 0, one of the numbers must be 0. If I'm thinking of three numbers and I multiply them together, I get 0. What do I know about the numbers? If they multiply to 0, still one of them must be 0. So same response. I'm thinking of two different numbers here, but now it's my number plus 1 or a number minus 2. And when I multiply those together, I get 0. One of the numbers after the calculation is done must make a 0. What number can I put where this question mark is so that when I add 1, I get 0? -1. -1 plus 1 is 0. So one of my numbers is -1. My other number, if I minus 2, I have to make 0. So my other number must be +2. Because +2 minus 2 is 0. And if I multiply 0 or any other number, I'm going to get 0. So here's the last one. When I have these sets of parentheses, x minus 4 and x plus 3, what numbers can I put for the x's so that when they're multiplied, I get 0? Well, one option is +4, because 4 minus 4 would make 0. And 0 times anything else in here would still equal 0. My other option is -3, because -3 plus 3 is 0, and 0 times anything else is still going to make 0. We're going to be doing this process today, where we factor and solve for x to get 0. So here's a few more examples of that exact same skill. What number can I put in for x so that when they get multiplied, I get 0? Look at each piece separately. It's called zero product property. The first one, what minus 2? Oh, it's 2. 2 minus 2 would make 0. And the other one, something plus 8. So -8 plus 8 would make 0. If you want to be more technically correct, you can write that x equals. X equals. I'll do part B, and you can do problems C and D. So here I see I want them to multiply, the parentheses to multiply and equal 0. So my x number, something minus 1, x would be +1. +1 minus 1 makes 0. My other one is harder. This is going to be a fraction. If the 3 was not here, something minus 9 is 0. Well, it would be +9 minus 9. So my first thought is 9, but because that 3 is in front of the x, that changes my answer. To finish solving for x to get the x by itself, to undo a 3, we would have to divide by 3. This is just my mental thinking. So 9 divided by 3 is 3. And then you could check that. 3 times 3 is 9, and then minus 9 does make 0. So you can try these last ones, figuring out what the x would be to get to 0. It's called the zero product property. Now, how do we use that to help us mathematically? Question A, rewrite the quadratic equation as a product using factoring. When you hear that word factoring, you should think, is there any number that all the terms can be divided by? 2, 5, and 12. No, they cannot all be divided by 2 or anything else, so then we're going to use the rectangle and diamond problem. The 2x squared and the negative 12 go in the diagonal, and then they get multiplied. So 2x squared. If we multiply 2x squared times minus 12, that's negative 24x squared. That diagonal multiplies to the same thing as the other diagonal, and we put this plus 5x here in the bottom of our diamond pattern. And we're trying to pick two numbers that are going to multiply to negative 24 and add to 5. It's helpful to make a list. 24 times 1, 12 and 2, 3 and 8, 6 and 4. Do any of these add to 5 if we put in a negative? 3 and 8. Which number should be negative so that I can get to positive 5? 8 minus 3 would make positive 5. So my numbers are going to be negative 3 and 8. And you need an x with each one so that when you add them, it does make 5x. And when you multiply x times x, you get the x squared. So we've got negative 3x and 8x as our missing numbers. And then we look for the common factors that we can take out of each row. So going across the bottom, these both have an x and they can both be divided by 2. So we've got 2x. 2x multiplied by another x would make this box of x squared. Check. 2x multiplied by 4 would make this box an 8x. X multiplied by minus 3 would make a negative 3x box. And negative 3 times 4 is negative 12. Our last job is to write these in parentheses. X plus 4 and 2x minus 3. This is factoring. Rewrite it as a project using factoring. Part B. Now that the equation is written as a product of factors equals 0, you can use the zero product property. So we're going to take each of those factors, x plus 4 and 2x minus 3, set them equal to 0. And I'm asking myself, what number can I plug in as x so that when they multiply, they get 0? The first one is negative 4, because negative 4 plus 4 equals 0. So x is negative 4. The second one, students typically say, oh, I see that it's something minus 3. So the answer must be 3 minus 3 equals 0. But that's not true because of this extra 2 in the front. So we have to account for that by not just writing 3, but we have to undo the 2 like we're solving for x by dividing by 2. Another way to look at this is to simply write out all the steps. 2x minus 3, and it's equal to 0. So if I was to solve for x, I would start by adding 3 on both sides. We get 2x equals 3. But then we have to undo the 2 by dividing by 2. And 3 divided by 2 is 1.5. So our x equals 1.5. That's called the zero product property. Our last step, question C. These answers represent the two different x-intercepts on the graph of this quadratic. Write your answers. Use your answers to write the coordinates of the x-intercepts. So what that means is on a graph, if you used a graphing calculator or Desmos or a graphing website, this original equation we started with up here is a graph of a U shape that's something like this. And the numbers that we just got is this x-intercept here at negative 4, and the y height is 0. So as a coordinate, it's negative 4, 0. And our other x-intercept that we got was 1.5 and a height of 0. So as an x-intercept coordinate, it's 1.5, 0. I'll do one more example, and you'll do the last page on your own. Find the x-intercepts for the parabola y equals x squared minus 2x minus 8. Use factoring and the zero product property. Okay, so factoring, that's the rectangle and diamond. That's really big. X squared and the minus 8 go into the diagonal, and we multiply those. And then the minus 2x goes into the bottom of our diamond pattern. And we're trying to find a pair of numbers that are going to multiply to negative 8, but add to negative 2. So start listing. They could be 8 times 1, 2 times 4. Oh, 2 and 4. That could make negative 2. If the negative 4 is the larger one. So negative 4, and I add 2 to that, I would get negative 2. And negative 4 times 2 is negative 8. And they need x's with them to match the type of terms in our pattern. 2x and negative 4x. Put those in as my missing numbers. Because this rectangle is an x squared, I know that must be an x times an x. And along the bottom, the x must be multiplied by a negative 4 to make negative 4x. And along the top, x must get multiplied by 2 to make 2x. And if we double check, 2 times negative 4 is negative 8. So we write that in parentheses. That's a factoring. Final answer for factoring. But now we're finding x-intercepts, so we're wondering when does it equal 0? And so we're finding those numbers that cause this to be equal to 0. If I had a positive 4, 4 minus 4 is equal to 0. If you wanted to show the work, you can just write x minus 4 equals 0 and add 4 on both sides to also get x equals 4. And my other number, negative 2 plus 2 would make 0. Technically, the directions asked us to find the x-intercepts, so to write them as x-intercepts, we should write them as coordinates. 4, 0, and negative 2, 0. I don't ever ask you to make the graph, but if you were graphing this, you'd have a dot here at negative 2, and a dot over at 4, and that U-shaped quadratic parabola that goes through the x-intercepts. You're going to try these ones by factoring and then using the zero product property to find when they would be equal to 0 and getting 2 answers for x.